Okay, so we're going to look at two-way tables, and we're back to Unit 4 probability. And some people struggled with this and trying to calculate probabilities, and even if you didn't struggle with it, you probably need to refresh yourself on some of these notation symbols used for probability. Back in paragraph 8 of the transcript, they said that saliva-based tests were nearly 90% accurate. Here are some follow-up percentages to see if you can use this information to create a two-way table and answer some of the probability questions. So pause it where if you want to calculate it yourself and see if you're right. But maybe try to fill this in. Maybe pause it right now and fill in this two-way table based on the information provided here. But I'm going to go ahead and do it. All right. And let's see, we've got 50 patients that were given the standard test and 50 that were given the saliva test. So I'll put those numbers there. So I had 100 people in all. And that makes it nice from a probability standpoint. Actually, 88% it was accurate. So they said nearly 90%, but 88%. So when it was a saliva test, so out of this 50, 88%. So I just did 0.88 times the 50, and I got 44 over here. And then just doing the quick math, just subtracting to make sure it adds up. Then they said the overall probability that a child was tested with inaccurate result was 22%. Overall is standard and saliva combined, so 22%. So 22 out of the 100 it came up inaccurate. So then backing in to math over here and then backing in to this one. Now we have our table. Ooh, and one more last thing. Checking it, 78, checking it this way, checking it this way. It's like Santa Claus checking it twice. And so we have the information, and those are counts, but we can change it to percentages as we need to. And nice because it's all out of 100. So you could literally go in here, make sure you get that 0 in front. Now we've changed it to not counts, but percentages. All right. So probability that standard, what is this? Given. Probability that it was the standard test given that it was not accurate. So where is this given that it's not accurate? I'm going to go to my highlighter and say, okay, well, where is it not accurate? Well, it's this whole row down here. So this is the 22% of inaccurate results. And within that, what's the probability that they were standard given they were inaccurate? So it's out of that, I'm going to just undo that highlighted part just because I want to use this over and over. So standard was the 0.16 out of that 0.22. So, I'm just going to pop over here to my calculator and do that real quick, and it turns out 0.72 repeating, 0.7272, so forth, repeating. So about 73% of the time, given that it was not accurate, that it was a standard test. All right. That symbol right there is the intersection of the two. And to me, the best visual way to show an intersection is to highlight the saliva group, highlight the accurate group, and look for where it's overlapped. Well, and it's overlapped at the 0.44, so that is the intersection of those two, 0.44. You might recall a formula that says the probability of the intersection of, say, accurate intersect saliva. Ugh, sounds gross. Accurate intersect saliva would be the probability of accurate times the probability of saliva. Well, that is if they are independent. Keep that in mind. All right, we'll see where that comes into play later. All right, keep that in mind. And then the probability that accurate, whatever that is, well, that means not accurate. That is a tick mark or prime. I think they use in geometry, but the probability that it's not accurate. All right, so accurate was 0.78, and not accurate is 0.22. So this also means the same thing. It means the complement of accurate. So that's 1 minus the accurate group. So it's still 0.22. And then U for union, it's also known as an OR statement. So it's this or this. And so now we've got saliva or, ooh, can I do this? No, I can't. I don't think so. Anyway, I've got saliva or accurate. So we've got saliva, saliva, and then we've got accurate, accurate. I don't want to double count this, but it's all three of those added up. Or 1 minus the 0.16 over here. 1 minus the 0.16, so that's 0.84. Sorry, 0.84. And then, are the test method and results independent of each other? You remembered. We're going to check this formula. The intersection of the two, the 0.44, is it equal to the probability of accurate, 0.78, times the probability of saliva, 0.5. A little quick calculation with my calculator, and I get 0.78 times 0.5, or half of 0.78 is 0.39. Silly me, I didn't need to do that with the calculator. Alright, so, and they aren't. So they're not independent. There is some relationship here. And I think you can kind of see that the saliva test is a little bit better than the standard test. Okay, next little video. Sorry that went on a little long, but it was good to get those symbols. Next one, we're going to incorporate a, wait for it, tree diagram. All right, join me in that one.